Okay. Uh, so, hi all. Thanks for showing up. Feel free to put comments in, and I will try to answer any questions you have as this goes along. So today I'm going to be talking about cloud native build packs, um, and just to set expectations and other levels. I'm by no means an expert on this. This is me coming to a new thing and kind of looking at it and being like, is this something I should use? And I'll admit I came to it kind of skeptically for a number of reasons, but mostly because I've kind of become skeptical about a lot of the new, basically anything that's added to the container space. Um, not because I think any of it's bad. It's just um, as things go on with containers, it seems like everything is just getting monumentally more complicated with less value add. So kind of the way I think of it is like I started with Docker and Docker made sense. And then like, oh, you need to use Kubernetes. And okay, let me look at Kubernetes. And Kubernetes is pretty complex, but it's easy to kind of figure out, okay, this complexity has a certain amount of value. And then like, oh, you're using Kubernetes and containers, you should use Istio. Like, okay. And then I kind of explored Istio and like, I kind of get the value of it, but again, it's like a lot of complexity for not a tremendous amount of value in my humble opinion. Um, and then, and like you can keep doing this with every single thing that's added to the Kubernetes and container ecosystem. It just becomes a lot more complex to do. Like I just want to install an app, right? I just want to do Hello World. It becomes harder and harder and harder to do. And so that was sort of my mindset coming into Buildpacks. I thought like, oh, this is just like another one of those things that is, um, uh, complexity without a lot of value. I'm wrong. I was wrong in that, and I'll get to this and kind of show that I think that build packs actually are really cool. And if you take nothing away from it, take this that my belief is that all of these technologies are kind of converging to make sure that the developer experience matches the serverless developer experience wherever you are. And that idea of like I just do code and I say push it somewhere and it runs. And I think anything that leads that to being more true is going to be successful. And so build packs, I think, definitely fill that role. Build packs, like so. Let me go to the let's go to the website buildpacks.io. And you go here, and it says up here, transform your application source code into images that can run on any cloud. And that seems a little markety, which is weird because I know that this is all open source. It's all part of the Cloud Native Foundation, Cloud Native Computing Foundation. Sorry, I knew I left off a letter. But and like why native build packs? Control, compliance, maintainability. So and again, my understanding is flawed, so I may be oversimplifying it. But basically, this build packs are a way to take code and without having to mess around with Docker, create a Docker image out of it. Um, and so what I'm going to do is I'm actually going to switch to some code here, and I'm gonna have to code. I don't like live coding, but I think for this part, it's important for me to show you what live coding looks like here, because talk about all the different parts. So I'm gonna do this in Go, and hopefully this will give you an idea of what the experience with build packs are like. And then what I'm going to do is I'm going to go through and try to recreate what build packs give me using my own knowledge and Docker. And I think that's kind of instructive of something here. So let's see. So func main. So I'm going to build a small web server. And so for those of you maybe that don't know Go, this is a really simple operation in Go. Serve. Let's see. So listen and serve takes, basically this is setting up the web server, and it takes two arguments, which is the port and a handler function. I'm going to leave that nil for now. And then error not equal nil. We're going to fatal. So basically, if I try to start up the web server and it fails for some reason, we're going to throw an error. Error starting web service. Okay. All right. So okay. So I have a web server set up. I didn't get any errors. So I think that's good, decent code. So I'm going to write a handler func, and call it index handler. And this will of course be a hello world. And I just know off the top of my head, because I've been practicing. I'm not getting completion here for some reason. Grr. That's all right. I wrote all this code yesterday and have it at the ready. So let me just grab this. All right. And all we want to do here is all right. Now I know this is a little extraneous of me live coding this, but bear with me here, because it's important for you to see how the code is structured as we go through and try to build it. Okay. All right. So one last thing we need to do, which is HTTP handler, and it is slash, and we're going to send all of that to index handle. Okay. So let's test this real quick. Go run main go. Error. Non-declaration statement outside function body 13. Oh. Okay. That's just dumb of me. There we go. All right, so that should work. Oh. All of my stuff isn't working, like all of the imports and stuff. This is what I get for updating the Go package right before I got on. All right, so all the imports are missing. Let me just real quick make sure that use language server. Huh. Okay, so hold on a sec. I apologize for this. Go. Language server. Go dot. Format tool. Saying that is an error. There we go. All right. Let's see if that changes things. Yes. All right, good. So that's now working, but it's not grabbing HTTP, which is annoying. All right. So net HTTP. And now we know I don't like live coding. Oh, that's because it's handler func. There we go. Too many arguments. Huh? All right. It's handle func. There we go. All right, now does it work? Yep. Okay, good. All right, so we're going to allow, and then we're going to go and see, and we'll go 80, hello world. Great. All right. So this is a basic web server running on port 80, spitting out hello world. How does this work with pack? So I'm going to go ahead and pack build and hello world. Okay. All right, so let's look at this. Please select the default builder and suggest builders. It looks like it's making a query, and we got a bunch. Please select a default builder, or I probably could enter a command line option, but I'll probably set it because the options, this is the ones it's suggesting are Google, Heroku, and Paketo, and you know, I got to know where my paychecks come from, so I will do it from Google. Also, it's probably going to be the most compatible with the type of work I've been doing, so there's also that less cynical reason to choose the Google one. Okay, so now when I pack build hello world, what's my experience? Okay, I get like a lot of stuff being printed out, and it successfully built an image. Now I just happen to know that the output of pack is supposed to be an image, a Docker image. So let's look. And we'll see here that there is in fact a hello world image. I don't know why it was created 40 years ago. It is the one I just created. And it's 120 megs. Okay. All right, so that's all set. And so if I Docker, let's see if I can remember all the command line. I want to run, I want to detach, and I want it on 8080 to 8080, and hello world. Okay, Docker PS. Okay, good, it's running. So now if I go here and look, we're still running. All right, so nothing too crazy about that pack experience. It was nice. It was nice to create a Docker file and be able to go with it. But also, I think this is way too simplistic an example of code. I'm not gonna try to do something crazy in front of you. But what I do want to do is add a dependency, because right now this app is pretty boring. And doesn't really do much, but most apps are going to pull in dependencies, and this is where it becomes more challenging to build something, just dealing with dependencies in general. So I have code in mind. I have a random code generator library that I have on my GitHub account. So I am going to copy and paste because I'm lazy. And let's make this happen. So it's the library name is Shades, and I think it's so let's see, Shade error Shades new family, good. And I just basically want, instead of like a color family of like red or blue, I just want all. So I want a random color from all of that. We're gonna trap errors. If error is not equal nil, then we're going to, first thing we should do is throw an error. So write header, we're going to throw HTTP status internal server error, and then we're just going to steal this. I don't feel like typing it all. Error. Go. And then finally we're going to return so that we stop processing. But that shouldn't be a problem. That should just work. So what we want to do is instead print out shade.random. Okay. So the last thing I want to do is I want to add a handler for it so that we actually listen for it. And then random handle. All right. So let's make sure this is working. Allow. And and let's see here. 8080 slash random. Okay, and I'm getting random color values. Great. Not very exciting, but it works. That's good. What I want to do is say pack build hello world, and this is weird. Oh, there we go. Just pulling stuff, pulling it all down. Okay, and it built a working hello world. Great. So that doesn't seem that crazy, right? Like I just basically spit something else in the middle here to create my Docker files for me, to create my Docker images for me. But if you look, all I have here is this main.go file, which is actually pretty cool. Like I didn't have to set up a Docker file and try to get that running and working. And so let me just kind of walk through what I would have to do in order to get a working Docker file here. Because I think that is relevant. So let me go ahead and we're going to pack. We're going to create a Docker file. All right, and I usually go from Debian, and then so I need the Go executable. So typically, what I do is I build the Go executable and then shove it into the container and then push the container, and that so like we can do that real quick, but that requires me to make stuff other than okay. All right, this isn't too bad. Well, you know what? Like, so the problem with doing that is that when I go to a build step, like if I push it to cloud build or something, I have to create the executable in cloud build. So I guess the easiest way to solve this problem is to do a multi-stage build. No, not a multi-stage build. Just build. Just what am I talking about? I'm getting ahead of myself. All right. So instead of going from Debian, we're going to go from Golang. And we're going to copy, we're going to run make dir go / source / hello world. Okay, we got to make sure that directory exists. And then we're going to copy main.go to go source hello world. And then we're going to run go build. So I want to output to, let's see, go /bin / hello world. And I want to yes, I'm copying and pasting. I have no shame about it. Okay, that all looks right. And then we just want to make the entry point to be that output. Go file entry point. Okay, this should work. All right, so let's go ahead and Docker build t hello world. That should work. Okay, we're loading up Docker. Now we get an error. Okay, so what is the error? Cannot find package. Okay, so we run into a problem with the dependency. So what I need to do is add a line to download dependencies. So let's go ahead and do that. We're going to go run go get. No go file. Oh, I gotta get the directory right. Okay. So let's see. I guess I can cd into that directory, source directory, and go get. Let's do that. Okay. All right. Now that works. Okay. So okay, let's test it. Let's make sure it's working. Okay, good. It's working. So let me just kill that one so we can get back that port. Mantic Joliot. That is a good random one. Docker stop. Okay. Okay. So this isn't a tremendous amount of more work in order to get that same experience, right? So now instead of having the pack file do all this work for me, I just had a Docker. I'm sorry. Instead of the build pack doing it for me, I have the Docker file doing it. But there are a couple disadvantages here. So if I go to Docker images, we'll see that the new Hello World tag here is 854 megabytes, so close to a gig. And so this is annoying. This is a very big Docker image for the very small amount of code, which honestly is not a huge problem. Like for a couple of reasons. One, there's a bunch of ways of getting this smaller. But well, why don't we go through and do that, right? Because that would be important to see. So now is where we get to multi-stage builds. So the first thing I'm going to do is give this a alias as G, and then what we're going to do is we're going to say from Debian. We're going to copy from G, and we want to copy the binary file that we created. So go bin hello world, and we can just copy it straight to slash, and we can do it this way. Hello world. That should work. So let's see if that works. I'm not confident that it'll work, but I think it'll work. Okay, it works. All right, and let me make sure that the image works. We're running it now, and yep, everything works. Great. Okay, so what are we at now for image size? So hello world, we got the latest, and it's 121 megs. So when we started with pack, it was 120 megs. With the Golang Docker image as a starting spot, we got to 854, and now we've lowered it down to 121. I think we can go lower though. We can go lower. And I'm just going to do that just because it's fun. I'm going to put this to Scratch instead of to Debian. And let's see how I do there. Okay. So build. Okay. Let's kill the one I had. Docker stop mystifying Euclid. All right, and if anybody has questions, feel free to drop them in the live chat. All right, so we're gonna run the latest version of it, and it's gonna fail. Okay. So this is because it's because I haven't added some options to when I build the Go file. So I'm gonna go ahead And where is it? Yeah. So it's this one. I learned this through experimentation. So let's see. So this should work now. Let's try it again. Nope. I got to rebuild it. Nope. Do I have to add both of them? Maybe I have to add both of them. Or all of it. Let's just add this whole thing to the build step. There we go. Nope, still not working. This is weird because I had this working yesterday. I'm not sure if I want to spend a lot more time working on this. Just because I don't think it's that relevant or important. All right. I'm going to stop there, and now I'm going to kind of talk about some of what we saw here. So, so even if I got that to work, and like I have gotten to work, I'm just missing like a command flag somewhere. This gets that image down to 6.5 megs, which is nice. It's nice to be pushing something that's small around the network, especially for the service as small as this. But I'll argue that this 121 and 120 aren't like completely inappropriately large. And you know, I think I've seen a bunch of workloads that like that's fine. And that's not crazy large. Certainly not for you know, development and testing purposes. Okay. So I used Pack, and I used it to generate these Docker files, and I saved myself a whole lot of work. So if I go back here to this one, will actually work and build. So let's do that. Okay. For images, we want to run. Okay. So let's kind of compare and contrast those two experiences. So the first thing I did was I had to just run pack build hello world. I didn't have anything else in my drive. I didn't have a Docker file. I didn't have any YAML or anything. I just had the executable, and that was a great experience. And like I didn't have to, you know, like once I added the Docker file and tried to make this work with Docker, it added a lot more complexity and issues to what I was trying to do. And basically, if my goal, and for not a lot of value, right? Like the Docker file that I created was, you know, just was almost exactly the same size as the one created by Pack. However, what's important is if you go through, and you know, I actually started going through and looking at the builder's code for a lot of this. Let's see if we can see it in here. Nope, not that one. You see it. It's doing a lot of things where it's setting up arguments and setting user IDs, and like it's basically doing the right security stuff for your Docker package, for your Docker image right from the get-go. In addition to a whole bunch of other work it's doing. I don't know what all these libraries are. I don't know why all these things are being added. And quite frankly, I don't know that I need to know, because the people that made these Buildpacks, you know, who checked this in, Lucas Berger, like he knows this stuff a lot better than I do. And makes a much better container package than I'm able to make with my kind of broad knowledge of how to make this stuff work. And so that, I think, is where this is really exciting. for less work, right? Like, I don't have to wrestle this Docker file and, and wrestle this to make this work. I'm able to create a Docker image. It's more secure than I would have written it myself, because I didn't bother with changing around the user IDs and all of that stuff. And I'm able to kind of move faster from there. So, my conceit that I said earlier in when I was talking, is that I really think that developer experience being like serverless is the holy grail. You as a developer, I don't want to spend a lot of time kind of on the details of how it will run. What will the environment that it runs like be? And that's a lot of what you do with Docker and any sort of container receiving technologies. You have to spend a lot of time building up that environment in ways that, in ways that it's hard to become an expert in as a developer. And what I mean by that is, if you're, as a developer, you're spending a lot of time working on the code, adding features, and it makes sense that you'd have a lot of knowledge in those working parts. But with the systems bit, a lot of times, like, you just get it working, and then you almost never touch it again, until a couple months later, and you need to get it up and running again, get development up and running again, and you find out that your dependencies are broken and whatnot. So you basically spend a lot of your time and effort getting just this build system working so that it can run wherever it's going to go, and then you spend the rest of your time on a daily basis, on a recurring basis, working on the code. And so that becomes really important. You're going to be a more expert on the code and less an expert on the systems work to get the code to run somewhere. And so this just completely cuts off all of that, right? All I have to do is I write some code. I go back here, I delete my Docker file. Yep. And then I say pack build hello world. And it's as if it's as if I didn't need that Docker file at all, because I didn't. And so that's great. And I think that's I think this matches for me the developer experience I got when I first started trying out App Engine, where like I didn't have to worry about setting it up for where it was going. I just gcloud app deploy or whatever the command was back when I first started using it, and it just went there and started working. And so I think this, just one command and you've got an image without a lot of configuration files to mess around with. And I think this is a much better experience. I'm sorry, I'm babbling, because normally these go longer, but I think I'm done, right? I think I showed what you want to see. So the question is kind of to wrap up, to close it out. Should you use Buildpacks? And my answer to this is, absolutely you should use them, but you should understand what I think they are. So since the output is a Docker file, a Docker image, you would be right in assuming that like there's nothing you can do with there's no artifact. Well, that's not true, because I'm sure someone will come along and say, well, like you can set the build output to be something else. But I guess what I'm trying to say is the most common output I see from this is going to be Docker images. And since Docker image can also be created by Docker, and under the covers, that's obviously what this thing is doing. It's using Docker to create these images and whatnot. You having a knowledge of how Docker works and how containerization works is still going to be important using a build pack. And so that, in my mind, kind of the metaphor I draw for it, sorry, I hit the microphone. The metaphor I draw for it is it reminds me of JavaScript frameworks. in the sense that like I can see this opening up running on containers to a lot of people who maybe just don't get or probably not get isn't fair. It's more like don't have the time to understand how containers works. Like they're doing other things and they just they have their host on a containerized system, and this allows them to build a very secure, well done container without having to know how containers work under the covers, which is great. And so that's going to bring more people into containerized computing, which is good. However, like a JavaScript framework, it's going to take care of 90% of the use cases, and then you're still going to run into issues where like the tool, because it's an abstraction, makes the ultimate outcome you want not possible. Like for example, if I want a really really super small Docker image, I haven't figured out a way to get Buildpacks to do that, other than writing my own build pack that uses Scratch as an ultimate destination, which I just didn't do. But then again, if I'm going to do all that work, why don't I just do it in the Docker file, which I know already? So there are going to be times and places where you use Buildpacks and it just makes things easy and fast. And for the vast majority of uses you have, like, I just want to set up the server and try this out, see if it works. Buildpacks are going to be great for that. But there's going to come times where you have very specific needs that Buildpacks don't handle, and you're going to need to dip down into your Docker knowledge, your Docker file knowledge, in order to solve those problems. And that's great. And like I said, that's exactly what a JavaScript framework is like. It empowers a whole bunch of people to get involved and get into it without understanding necessarily the complexity of the JavaScript underneath. However, you're going to get a lot of value out of knowing that complexity underneath. So make sure you don't throw out your Dockerfile knowledge just because Buildpacks to some degree make it superfluous. But no, this is cool. And like I said, like this makes me happy. And I think that I'm going to start incorporating Buildpacks into my projects pretty much right away, because not having to wrestle, like being able to not wrestle with the Docker file and all of that's pretty rote, just to see if a project works and we're working in that context is really kind of helpful. So yeah, I love these. And an important thing to note is that the Cloud Builder one that I'm using is evidently related to the technologies that we use to launch code on App Engine and Cloud Functions. So we are Google Cloud at least is already using these pieces of technology internally to drive some of our platforms, and there's already in alpha is the ability to incorporate Pack into your cloud build routines. So this is great, and I, like I said, I think I'm really going to start using it, and I really recommend you take a look at it. Just if nothing else, for that experience of like not having to worry about a Docker file. All right, so I'm going to hang out for a minute or two, see if there's any questions. Otherwise, thank you very much for watching.